Okay, good morning. Almost noon. I'm going to continue right where I left off, kind of. In the last video, I was looking at this code here on the left, but while I was uploading the recording of that video, I kept coding on the left and added more code. So, kind of where we left it when we stopped last time was my zoo did not have a feed animals method yet. I just put the keyword pass there, which kind of means do nothing. It's often used as a placeholder. You can also raise an exception called not implemented. If you have a method that you don't want people calling yet, you can just put raise not implemented. You can raise exceptions. You consciously um, tell people when they make a mistake by raising exceptions. It's kind of like throwing a flag in football or other sports. When there's a foul, some referee throws a flag and blows a whistle. You're encouraged to write your code that way too. Just go ahead and raise exceptions sometimes. And then there are ways you can catch those exceptions and deal with them. Just like in football. The game is not over when someone throws the flag. It's not like, oh, game's over, everyone go home now. No, there's a penalty or some other way to, fix it. And then you keep going, right? So exceptions need not be fatal. We haven't done any programming with exceptions much. There was some in this primes play earlier. I had an exception consciously raised if you did not pass in an integer. You're asking for factors of like a floating point number. Don't do it, right? So raise a value error there. So here I'm going to raise a value error if you ask to feed the animals, but you haven't hired a zookeeper yet. So one of my methods after you've created a zoo type object, is to hire the zookeeper. And if you try to feed the animals and you have not you've not hired a zookeeper, then I raise this value error, no zookeeper hired. And I figure out if you have or not by going into the dictionary of the zoo self and seeing if there's a ZK entry. Like ZK means zookeeper, right? So I'm bringing a zookeeper on board through the hire method. We already had add animals last time. Now, if you wanted to start all the way from the beginning of the source code and figure out what's going on, remember that each animal is a self-contained individual that has a stomach and is able to eat a food. That's the basic thing that an animal does. And then a zoo is basically a container for animals that we can loop over, and now we can hire a zookeeper to feed the animals, thanks to recent development. Now here's the zookeeper class. We've got the name. This is like a person, so we'll take like a first name, last name might work. Social security number. This is someone we're probably going to be paying. And we also need for them to read off a list of foods, because what do each animals eat? What does each animal eat? We don't want the zookeeper to have to memorize that, and the animals come and go for another thing. So there's just got to be this growing sort of shopping list or list of things, that each animal likes. So let's take a look at that. Here's a text file. And if you know a Python dictionary, this looks just like a Python dictionary. It so happens that JSON, JavaScript object notation, uses JavaScript objects. And JavaScript objects look like Python dictionaries. So this is simply a JavaScript object or dictionary that we're going to keep on the file tree in file storage between running this program. And so that the zookeeper can just look up the species and get the food that species wants to eat. So this could become a much longer list as we add more animals to the zoo. So the getFoods method It has a little underline in front, and that's mainly saying this is for internal use or official use only. It's like the ordinary user of this class, the zookeeper, you wouldn't normally run this method. It's run internally, right at the beginning. When we initialize the zookeeper, immediately the zookeeper needs access to this file, the one we just looked at. So what happens, we use the open built-in method, open the file in read mode, and read it in as a string. And then we use a method in the JSON module. The JSON module is for reading and writing strings in this format, this data transfer format. It's used all over the place to send data to and from different computers. It's like they're all running different languages, different programs. They're all off in their own train of thought, but they all know how to talk to each other in JSON. So this is something you're going to come across quite a bit. That's why I put it in here. I want you to understand about JSON. So the feed animal routine is going to take advantage of our having already loaded this dictionary, and we're going to go through and look up inside of the foods. That's what we're getting out of this. We're getting foods. When we read the JSON file, we're figuring out the dictionary of what each animal eats by species. So when the zookeeper feeds an animal, all it needs is the animal name. And it's going to take that, not the animal name, the animal object itself. The actual animal object is passed in as an argument. Species is looked up basically by dot species, and that gets fed into foods using the get method saying, hey, what does this animal eat? Now, if for some reason that species is not listed, the way the get method works is it defaults over to the second argument you give it, in this case, pellet. So if I'm looking down this list and I don't see python or, some other animal, parrot, then I'm just going to feed it a pellet, whatever that means. I've just decided that pellet is kind of, instead of feeding it nothing at all, there should be an alert to the zookeeper, though, that we have a missing item, because pellet isn't what we'd really like to feed them. We want to feed them their preferred food. That's what pref food means here. So that's all the code. I've just gone through it all, but now I have to actually run it and see that it works. So I initialize the zoo object. This means I'm running the initialization method of the zoo, which only just creates a simple empty list called animals inside of the zoo. And then I run the add animals method that belongs to every zoo object. So every zoo instance that I create knows how to add animals to itself. I can create a lot of different zoos now. Now that I've done all this work and created a whole class for the zoo, I'm not limited to just one zoo. I can create a zoo for each major city on the planet and start populating it with all sorts of animals. Go really crazy here. And then I can hire a zookeeper for each and every zoo. But for here, I'm just going to hire Jill into the zoo. And then I'm going to feed the animals, which takes no arguments. We look up here, feed animals inside the zoo. Takes no arguments. Self is implied. Python knows what you mean when you call feed animals on zoo. It knows that the self you're talking about is the very self on the left here, to the left of the period. It's like this is the self, and it's automatically going to jump in and populate the leftmost argument. It's going to come in as self when you ask to feed the animals. So there's the zoo coming in, and first of all, if there's no zookeeper, we're in trouble. But if there is, we're going to loop over all the animals in the zoo, and each animal we get, we're going to give it to the zookeeper to take care of. And that's what the zk.feedAnimal is saying. We have to jump back down into the zookeeper to see where that method lives. And that's where the animal comes in. Okay, got to take care of the lion. We don't know it's a lion yet. We just know it's an animal. We pick out the species and look it up in the foods, which we got from JSON, and feed it its preferred food. Remember, we're looking up in this list, read in earlier by the zookeeper. So that's the total structure. Now, big drum roll. Does it run? Ba-da-ba-doom. It runs. And at the very end, we can see that each animal, thanks to this printout here, this report at the very end, this for loop, is telling us the name of each animal in the zoo, its species, and what it's eaten so far. And the good news is each animal got to eat what it's supposed to eat based on its preference list. So this is so far a good test that the code is running as we like. So there you go. That's what Python programming is kind of like in a nutshell. It may seem that this is not a realistic application because who's involved in zookeeping? Actually, a lot of people. So they might use Python similar to this, but you would need to start adding a front end, maybe a website, so that administrators could actually manage this through the web. So this would start to become code on a server somewhere, and the people using this code might not actually look at the source code. They just look at web forms, and the zookeeper has a mobile app on their phone, and they just need to point at the QR code on the cage, and it tells them everything they need to know about the upkeep there. So, in the real world, there's more bells and whistles, but here we're just learning the grammar of the Python language. Hope you've learned some. Talk to you soon.